What if you could secure your entire FastMCP server with just 2 environment variables and a single decorator? You'll see exactly how to transform a basic FastMCP app into a Google authenticated service, where every tool call automatically verifies the user's identity before execution. The pattern is simpler than you'd expect, and we'll walk through the minimal setup that makes it work. From FastMCP, import FastMCP. Hash authentication is automatically configured from environment. MCP equals FastMCP. Name equals Google Secured App. At MCP, tool. Async def protected tool query, SDR. A tool that requires Google authentication to access. Hash your tool implementation here. Return F processing authenticated request. Query. This demonstrates the OAuth proxy pattern for integrating traditional OAuth providers with modern RPC frameworks. The approach bridges Google's OAuth 2 flow with FastMCP's authentication system, allowing you to secure tools without modifying their core logic. What makes this distinctive is the complete separation between authentication configuration and business logic, achieved through environment-driven provider selection. The pattern works by delegating authentication to a dedicated provider component that handles the OAuth dance, token validation, and user context propagation. Your tools remain pure functions while the framework injects authentication context automatically, following the dependency injection principle. This creates a clean boundary where security concerns are handled at the infrastructure level, not within individual tools. This approach matters because it solves the common problem of integrating legacy authentication systems with modern architectures. You get enterprise-grade security without sacrificing developer experience, as tools remain simple functions while gaining automatic protection. The trade-off is initial setup complexity for the provider, but this pays off when securing dozens of tools with a single configuration. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI-integrated tools. It handles authentication, tool registration, and secure communication between your Python functions and AI models. Hash authentication is automatically configured from environment. MCP equals FastMCP. Name equals Google Secured App. This initializes the FastMCP client with Google authentication pulled from environment variables. The name parameter identifies this app in Google's security logs, enabling granular access control. This is the standard entry point pattern for all FastMCP applications. At MCP, tool. Async def protected tool query, SDR. A tool that requires Google authentication to access. This decorator exposes protected tool as an AI callable function with Google authentication enforced. The type hints and docstring automatically generate the tool's schema, while the async definition enables non-blocking execution for concurrent requests. Hash your tool implementation here. Return F processing authenticated request. Query. This placeholder marks where you implement the tool's core logic. The return statement demonstrates the expected output format, showing how the authenticated query gets processed and returned to the calling AI system. The pattern ensures consistent response handling. Always return a string that clearly indicates the operation's result, including the original query for traceability. This maintains compatibility with FastMCP's tool contract. FastMCP authentication pattern. The Google OAuth integration abstracts all token validation complexity behind a single provider class, while the MCP tool decorator maintains clean separation between authentication logic and business logic. Static token verification in development creates a false sense of security that disappears in production. So never use dev tokens in staging environments. This pattern lets you focus on tool implementation, while FastMCP handles the OAuth dance and token introspection.
The server that knows nothing about tokens verifies everything.